All right, so today we are going to be going over multi-value returning functions. So, quick recap in regards to functions. We've already talked about void functions, so that is a function that does a job but doesn't return any value. And then we have our single value returning function where we set the data type of the function to whatever data type we're trying to return, and then we return some answer. Next, we're going to be talking about multi-value returning functions. So the multi-value returning function, we're trying to get multiple answers back. This is a very minor set of the amount of functions that you will be writing, but we're going to kind of create some scenarios that we're going to ask you to use multi-value returning functions, even if it's not the way that you should do it, just because it can be hard to come up with some examples and you really need to practice with them anyway. So, that disclaimer out of the way. So, how does this work? Well, first of all, we all of the functions that we've talked about so far, all the parameters are passed. They are passed by value or passed by copy. So this means that we are in memory creating a copy of that variable, passing that copy into the function. And if we make any changes to the variable inside the function, then those are not reflected in the main part of our program. Now, instead, we're going to talk about a second way that we can pass variables, which is called passing by reference. Now, next bullet point here, a pass by reference is the summary of it is passing in the location in memory where a variable is located, not the actual value. So you don't have to worry about this too much. It's very simple to do this change, but under the hood, what's happening is instead of saying, here's a 7, I want you to make a copy of this and store this somewhere in memory and use this for the function. Instead, it says, here's the address where this variable is located. You can update that variable instead. Use it for your own purposes inside of the function. So, essentially, we have two things that are pointing to the exact same location in memory. If one updates it, the other sees the updated value. That's what pass by reference is. So now, this gives our functions access to the location of a variable the caller is using. So as a result, we can change the value of that variable, and it will change it for the caller as well. Now remember, this is different than pass by value. So we're not making a copy. We're not making a copy. If you do the change inside the function, it will change in the main part of your program. Now, so you got to make sure that this is what you actually want. So as a really quick summary, what we do, we're not returning anything. We're not returning, I'm doing air quotes here. We're not returning anything. So our function is a void function. And then we pass variables in that will be modified by the function directly. So we pass them by reference. We can mix and match. We can do half of our variables are passed by copy or passed by value, and the other half are passed by reference. So if we update those ones that are passed by reference, they will be updated in the main part of our program. Okay? And then these variable modifications are our output from the function, our quote unquote output from the function. So we make it a void function because we're not using the return keyword, and we set values to these variables, and that is our quote unquote output. So just to show a real quick example, like this is how simple it is to change from passing by value to passing by reference. The only difference here is we have the ampersand. You can also, just in case you're Googling around and you see this, you can put the ampersand right next to the data type like I do and like I like to do, or you can put int space ampersand. It really does not matter, but I just like to put it like that. So just in case you see that. So we have a regular function here, swap vars with int var1, int var2. The only difference here is the ampersand. We add the ampersand. Now this variable points to the exact variable that was passed into it. And don't worry, we'll trace some stuff that doesn't make sense. But just know that if I change var1, it will change in the calling program. So in the main body of our program, whatever variable we pass in here will get modified inside of this function. Okay. So I had just talked about we set this to void. Well, can we return a value too? Yes, you can. Yeah, you can. There's nothing to say that you can't do that, but there's nothing built into C++ that says we have to use naming conventions either. So treat this the same way. This is just a convention. You don't do this. It gets real messy if you go outside of conventions. That's why we have conventions. So please follow this. Don't do this. It's bad form to do so. If you need a value returned from a multi-value return function, you pass the variable by reference instead. So, for example, if I just said, don't do this, int sum and diff, and then had all my variables in here, and I want to point out some things in this one as well, that this one is passed by value, or int1, int2 is passed by value, so copies of these are going to be made. So if I change these inside the function, it won't change in the main body of my program. But then my sum ants is passed by reference, and my diff ants is passed by reference. So if I change those values, they will get reflected back into main. But then it's also an int, so I'm returning some integer. What's the point of that returned integer? It's tough to say. Like it just doesn't make any sense. It seems like these should be the answers. That's why we don't do this, because it's confusing. If I look at this, if I look at anybody's function header, I should be able to figure out like this is exactly what this function does because you have a great name, you have perfectly named variables or parameters, parameters, and I just know what this function does generally. Well, with this, now I don't know what it does. So do this instead. So you notice I just changed it to a void, and these are my answers. So I pass in my variables, and I know that my answers are going to be whatever I passed in as my last two variables. Okay? So looking at these back to back, pass by value and a full function definition, and this is the exact same function definition. The only difference is we added our pass by reference, so our ampersand here. Well, if we call this function, temp gets var1. Yep, we've already seen this. We've already seen this code before, swapping variables, day one stuff, so hopefully that's simple. So we set temp to var1, and then var1 gets var2. So now this is not reflected back into main. var1 does not contain what's in var2 right now in main. Only in this function is that true. Then var2 gets temp again, only inside this function, because these are passed by value or passed by a copy. This one, on the other hand, is passed by reference. So our code doesn't change. We don't do anything different just because we're passing by reference. But when we do this line, var1 equals var2, at that moment, var1 contains the value that's in var2 in this function and back inside of main where we called this function. And var2 equals temp again. That basically sets var2 equal to var1 when we first started this, and that will be reflected back in main as well. So, okay, let's go to a little code trace that I've set up so that we can demonstrate some of this pass by reference versus the pass by value, and then lastly, we'll do a few example exercises, and hopefully this will make some more sense. So in this code trace, what I want to do is I want to say we have this set of code in main, and I'm going to put a little divider line here just so that we know that this is separate. And we have these function definitions, and you can notice that we're calling these functions here, and we're outputting the contents of variables A and B with a space in between them. And I want to know what's going to be written to the screen after all this code is ran. So I'm going to use red for everything that happens in main, blue for everything that happens inside the functions, and we will use green for our output, and we'll write that over here so that we can keep track of that. Okay, so first of all, we're going to start up here and we're going to run our first sets of code here where we're going to declare our variables A and B. So A, we create a bucket for that, and we set it to 7. Okay, now B gets another bucket too, and we got 2. Okay, so 7 and 2. So we see out A space B. So 7 space 2. So let's go ahead and do this right here. 7 space 2. Just going to do the underscore so that we know that it's a space. It's not an underscore, it's a space. Okay. Now, if we come in here, what we do is, so we did this line, and then we're going to call function 1, and we're passing in A and B. Now, I'm going to write up here so that I remember exactly what we're doing here, but that's a 7, and B is a 2. So I'm passing into function 1 a 7 and a 2. Now, if I come down to function 1, I can see that A is a pass by copy, so I'm going to take A here and create a bucket for it. And that's going to get passed in our first variable, which is 7. Okay. Now, int B, instead of a bucket, I want to think of it as an arrow or a set of directions that points to our B bucket up here in main. So whenever we do anything with B, we say, oh, here's an arrow. Let's go to this bucket up here, okay? And I'm going to refer to this as a pointer, all right? I'm going to call this a pointer. You can think of a pointer as a set of directions, like a P.O. box or something like that. It's directions to get somewhere in memory. Okay, so we passed in our variables. Then we set A equal to B. Well, A is 7 equals to B. B pointer to 2. So we replace 7 with 2. And then we do B plus plus. Okay, so B, follow the pointer, and we're changing this in main. So I'm changing to the color red, and 2 becomes a 3. Now we're at the end of the function, so we exit. And now we're at this line where we are going to see out A space B again. So if I come over here, I'm going to we see out 7 space 3. So let me do that, 7 space 3. Now we're going into the function again, a different one this time. This is function 2. Function 2, we're going to pass in A and B, so that's 7 and 3. So I'm going to write that down just so that I remember at this point in time what we had. Now if I look at function 2, let me delete my blues because these variables would be gone after we left the function. So now we're passing in an A that is a pointer. So A, and it's an arrow that points to A. And then B is here, 3. So we put a 3 in here. Now, the first thing that we do in here is we say A gets B plus 2. Okay, so A, follow the pointer, gets B plus 2. B is 3 plus 2, so that becomes 5. So 7 turns into a 5 in main. We executed this line, and then we set B equal to 0. Okay, B equals 0. Now keep in mind, that changes nothing in main because B was passed by value or passed by copy. So nothing changed in main there. Okay, so then we're at the bottom of the function, so we exit, and all of these blue variables are destroyed. And then we are back up here, and then we see out A space B end line. Okay. 5 space 3. Awesome. Now we enter into function 3. Function 3 is interesting because take note, B and then A. So I made these backwards. How does that change things? Well, let's see. So to be consistent, I'm going to write my values, even though it doesn't matter. They're both passed by reference. So 5 and 3. So the first thing that I'm passing is A, but that's B down here. So if I got to create a bucket down here in blue for what's inside the variable, or inside the function, excuse me. But what I passed into B was actually A. So B, the bucket B, actually points to the variable A in main, because it's the order that we're passing these in. Now next, we have the bucket A. And A points to B. So let's create a pointer here. Now, when we're down here, what we're doing is we're setting A equal to B. So we're saying this A, follow it here, equals this B, follow it. So we're essentially setting B equal to A in main. So that ends up being 3 turns to 5. Then we do B++. Well, what is B? B right here. Follow it up. 5 turns to a 6. And then we are done with this function. So let's erase our variables. Whoops, got a little too excited there. Put that back. Okay. Now we are here. Let's see out A and B again. So that's 6 space 5. 6 space 5. Now we're calling function 1 again. Just one more time. Just one more time. But we're calling it backwards now. We're calling B, comma, A. So that is a 5. And A is a 6. So when we get to function 1 here, our A is our first one. So let's create that bucket. And our A is passed by copy. So we copy in B, or 5. So A becomes 5. And then we create our second bucket, B. And this is passed by reference. So instead, we're going to make a little arrow here. And we passed in A there. So B actually points to A up in main. Okay. So our first step is A equals B. So A, which is 5, gets the contents of B. B, follow the arrow, 6. Okay. So 5 becomes 6. And then we do B++. B is right here. Follow the arrow. 6 turns to 7. We can do that. Now we are done with that function. So we delete all of our variables because we are done with them. And then we go back up to main. And now here we are. We're going to see out A space B. So that's a 7 and a 5. So a 7 space and a 5. Then we have our system pause, return 0. We're done. We're done. This is all the output that should come through with this. Now, luckily, I did run this program beforehand, so we can take a look at our results and make sure that everything matches up. So we have a 7 space 2, 7 space 2, 7 space 3, 7 and 3, 5 and 3, 5 and 3, 6 and 5, 6 and 5, 7 and 5. Cool. We got the correct answer. Now, if you're asking yourself, well, what was the point of all this? Why did you have such horrible variable names and all this stuff? These are all good criticisms. It's just an exercise. Hopefully you don't have as many complicated examples as this. When you're actually programming your own projects and stuff. But this is a good exercise, and you will definitely see this on some quiz/exams in the future. So please do get used to this and know how to trace like this. Now, next, let's code up some actual good examples where we would use a multi-value returning function. All right, so here we are. Let's do the first example as the swap variables function that I showed in the PowerPoint presentation. So we're going to declare our functions. We're going to do our function definition first. Let's say this is a void function because it's a multi-value returning function where we're going to swap the contents of two variables around. So technically we do have two outputs. We need to say this variable should be this and that variable should be that. That's a multi-value returning function. So when we get to our int var1, int var2, what we really need to do is we need to add our ampersand here to make both of these pass by reference. Now, when we make both of these pass by reference, this allows us to, like I said, modify the variable that's actually being passed to us rather than making a copy and then just modifying the copy. So back down in here, let's do our swap really quick. So int temp equals var1, var1 gets var2, and then var2 gets temp. And there you go. That's a simple swap. So let's grab this line right here and let's declare our function prototypes. Just like so. And then before I forget, let's do our documentation. So the purpose is to swap contents of var1 and var2. No assumptions, and our post will be contents of var2 will be in var1 and vice versa. Short, sweet, to the point. So now here, let's just declare two variables. We'll just call them A and B, just like we did in our code tracing there. Make this a 7, and then B equals 4. So really, if I see out A and then space B, just like we did in our code trace exercise, then we should see 7 and 4. And then when I call my swap and I pass in A and B, then what we should see when I repeat this cout statement here, where I output A and B, is that the contents are swapped. So it goes 7 space 4 and then 4 space 7. Let's see if we see that. Perfect. Exactly what we expected. Now, what I want to see really quick is, because we have a very simple example here of pass by reference, but what I want to do is I actually want to just remove this. I want to make it a pass by copy and just see how that changes things. How does that change? Because C++ doesn't have a problem with this at all. It doesn't have a problem with the fact that we're making a copy, passing it in, not doing anything actually, and then just exiting the function and losing all of our work. C++ does not care about that. So if I showed you this on a quiz, I expect that you would write 7 space 4 and then 7 space 4 twice. And let's see what the computer is going to do. Exactly that. Okay, so if you're getting some errors because things aren't getting updated like you expect them to, double check that you have that ampersand there. It is very important to make this a pass by reference call. All right, so let's move on to the next example. All right, so for the next example, what I want to do is I want to create a function that returns to me the sum and the difference between two numbers. So I'm going to call it sum and diff. Okay, so void sum and diff. And our first value is just going to be, we'll just call it int1. Whatever. We're just going to get some integers. We're going to add them and subtract them and return the results. So int2. And then next, this is going to be our answer. So this is going to be the answer for our sum at least. So we want to pass this by reference. So what we're going to do is we're going to declare an int by reference, and we're going to call this sum ants. You know, it's the answer to the sum question. And next, we're going to need to return another integer, passing it by reference as well, because this is what we're going to return in these variables. We're going to return the answer in these variables. We're going to call this diff ants. Okay, now let's grab this and do our function prototype really quick, like so. And then let's do our documentation. So the purpose of this function is to find the sum and difference between two integers. Well, the pre is the assumption that int1 and int2 contain the values you want to compare. And you know, what could be another decent assumption is that you don't care about the contents of sum ants and diff ants, because we're just going to overwrite those anyway. So it may be worth noting, post answers will be stored in sum ants and diff ants. Okay, so if I read that, I would know exactly what this is going to do. And now let's write this function. So, well, sum ants is pretty easy. That equals int1 plus int2, right? And then diff ants, well, that one's easy too. It's just int1 minus int2. Okay, so we got the sum, we got the difference. We're storing it in our variables that are passed by reference, and we're returning the value there. Now, you may be asking yourself, why are we not passing these two variables by reference? Because we have no need to. And if you don't have a need to, do not pass by reference. Without going too deep into it, but if you're interested, some keywords that you're looking for are side effects. So if you pass everything by reference, things can get modified and you may be unaware of it. And if things get modified and you're unaware of it, we call that an unintended side effect. So it's always best, and it's the reason why it's the default operation for most, if not all, programming languages to pass by copy or pass by value, is because that is the safer operation. You should only use pass by reference when you know that this is what you want to do. So since I'm not updating int1 or int2, and I don't want to update int1 or int2, I should pass them by copy. Okay? So we got our sum and our diff. Now we've got an a and a b, and let's declare two more variables because we're going to need them. Int sum and diff. Now if we come down here, we can say, let's call our function sum and diff. We'll pass in a and b, and then our sum ants will be stored in sum, and our diff ants will be stored in diff. So now with that function call, you'll notice it's a void function. We're not storing this in a variable. And by that, I mean, like, we're not doing ants equals or anything like that. We're just declaring it in a line because the answer will get stored in that variable and it'll get stored in that variable. Okay. Now if we come down here, we can do a cout statement where we say a plus b equals, and then we can output our sum that we calculated from our function there. And then if we take this same line, paste it down here, and let's just change this to a minus, and then change this to a diff. So what we're outputting is a plus b equals in the sum. So that sum should be 11. And then we're saying a minus b, or 7 minus 4, equals diff, or 7 minus 4 equals 3. So that's what we expect. So if everything works, that's what we'll see. And perfect. Worked great. Now what if just to make sure that the function is what's actually doing this for us, if we don't call the function, so we never set sum and diff, these values should contain garbage. Well, let's see what happens. Oh, build errors. Uninitialized local variable. Yep, for sure. So it does not work. So this function call is what's initializing those variables. All right. Now here in a second, we'll move on to the final example. All right, so for our final example, I figured this would be an okay function for us to write, would be find greater smaller. So the idea is we're going to pass in two integers, and it's going to set to a parameter that we call greater, the bigger of the two numbers, and there's another variable called smaller that we set the smaller of the two numbers. So this will allow us to do some sort of a sorting, filtering sort of thing. So first it's going to be a void because it's a multi-value returning function. Remember, find greater, smaller, int a, int b. So these are our two values that we're passing in, just a and b. And then int ampersand greater, because we're passing this by reference because we want whichever one is greater out of a and b to be stored here. And then the same thing here where we say int ampersand because we're passing by reference, and we'll call this smaller. So whichever one is smaller will get stored here. Now let's copy this and let's make our function prototype. Done. And then we'll declare our purpose. Our purpose is to find which value is greater and smaller. And I'm going to say we don't really have any assumptions. Yeah, I think that that's fair. So in our post is greater will contain the biggest value between a and b. And smaller will contain the smallest value between a and b. All right, so inside this function, really what we have to do is we have to say an if statement, because if a is greater than b, then greater gets a, right? If a is greater than b, then greater gets a. And then if that's true as well, then we know that smaller is b. Else, so this is a single alternative if statement where we're saying, well, if a is not greater than b, then that means that they're either a, they're equal, or b is bigger. Either case, it doesn't really matter. So we'll handle it the opposite way, where greater gets b and smaller gets a. Because if they're equal, then the greater and the smaller are the same, so it doesn't matter what we set them to. Okay, so we have the function done. So if that's true, then we'll set these values to this, else we're going to set the values to that. Now when we get in here, let's say we have an int greater and smaller. just like before. We're just going to declare these but not initialize them. And then we will call find greater smaller, and we're going to say A comma B, and then we'll pass in greater and we'll pass in smaller. Now when we're done, we can see out greater, and then we'll pass in our greater. And then next we can see out our smaller, and then smaller. So if we run this, what we expect is between 7 and 4, 7 is the bigger value, 4 is the smaller value. So we should get 7, greater 7, smaller 4. Perfect. Worked exactly like we wanted to. Great. All right, so I hope that example was helpful as well. If there's any questions, please let me know.